I'm going to explain how the tides work.
How do the sun and moon affect tides? Why do they differ across Earth? How does the geography of Earth affect the tides? Okay, so let's get started.
The moon has the greatest impact on tides, so let's start with that. As you've probably already heard, the moon's gravity attracts the water on its side of Earth, causing a tidal bulge. But let's dive deeper. The moon and Earth, contrary to popular belief, orbit a point near, but not quite on, the center of the Earth, instead of the moon orbiting the Earth. I'm going to assume that you already know about how the phases of the moon can be seen from Earth in differently. But the phase of the moon can also affect tides. As I mentioned before, the moon has the greatest impact on the gravitational pull of tides, but the sun's gravity affects the tides too, just to a lesser extent as it is much further away. During spring tides, which is shown here, when the moon and sun's alignment gives the tides an extra boost and causes extreme tides, so this would be the full moon and the new moon, and they're all lined up, so they give it much more of a pull here, and then so the water gets sucked out, so it's extreme high tides and extreme low tides. So low tides, high tides. This shows a neap tide when the moon is in the first and last quarter phase, and therefore the sun and the moon kind of cancel out each other's gravitational forces. As shown here, you can see that the sun is pulling away the water here, and the moon is pulling with a stronger gravitational force there. This causes a low tidal range, or a small difference between low and high tides. Extreme tides are when you have a really unusually big high tide and an unusually small low tide. And so an extreme tide was the spring tides from the last diagram. The neap tide is a really just small tides. But if the moon's gravity attracts water to create tides on its side of Earth, then why is the water on the other side of Earth opposite the moon bulge too? Well, remember how the moon and Earth orbit a shared center of mass? This causes two forces, which cause the other bulge. So, as the Earth spins, it creates centrifugal force, which literally flings the water on the side opposite the moon away from the Earth. Much like being on a carnival ride, if you've ever been on a really spinny carnival ride, as you're riding it, you feel a force acting on you that flings you to the wall, like the diagram. The other force that makes a bulge on the side of Earth opposite the moon is actually the moon's gravity. So while it does pull the water on its side of Earth towards itself, it pulls the Earth towards itself a little too, leaving behind the water on the opposite side of Earth. But wait a minute. I thought that Earth's gravity pulled the water towards it. Well, that is true, but water is much more free to move around than land. And also, in the grand scale of things, the amount of water being pulled out is very tiny. I mean, what are feet compared to light years? The tides aren't consistent across Earth, as I've mentioned before. Normally, there are 2 high tides a day and 2 low tides a day.
But in some places, you can get as few as 1 and as many as 4 high tides and low tides per day.
This cycle repeats every lunar day, or 24 hours and 50 minutes. This is why the tides change from day to day. We follow a solar calendar, but the tides follow a lunar calendar.
If you remember from earlier what the tide range is, it varies too.
This is because the continents interfere with the tidal sweep over Earth. So the water can't just sweep all the way over Earth. It has to go around the continents. Additionally, the moon orbits the Earth at a tilt, so the moon's gravitational pull doesn't act equally upon the whole entire Earth. So that, added to the fact that the continents interfere with the tides,
gives us the different amounts of high and low tides.
Without the continents, and with a straight orbit of the moon,
we would always have 2 equal high and low tides per day.
But then we wouldn't have land to live on, would we? Maybe some things are just meant to be. So now you know how moon's gravity and the sun create one tidal bulge, and centrifugal force and Earth's pull create the other. How the tilted orbit and continents cause the different amounts of high and low tides. Thanks for watching.